So now we're to the point where we finished testing all our individual aggregates for the different aggregate properties. The first one we're going to look at here is our coarse aggregate angularity. In this module, we will be blending the aggregate used in these blends. So let's look at the top portion of this page here and understand what the formula means. So CAA1 is actually the measured CAA value in each coarse aggregate test. The percent retained on the number 4 will be used in each calculation. So if you look at the table in the middle of the page, how do we get our percent retained? On that table, it tells us that we have 10% passing the number 4, so we're simply going to subtract that from 100, which gives us a 90% retained on the 4 for our number 78. On the number 8, which is also a number 60, we know that 15% is passing the 4. We're going to subtract that from 100, which is 85% retained, and also on the wrap. Knowing we have 67% passing the 4, subtract that from 100 is going to give 33% retained. The last portion is P1, P2, and so forth, and that is going to be the percent of that aggregate that is being put into this blend. So again, looking at the table in the middle of the page, you have your percent used, 25 on the 78s, 24% on the 60s, and 25% on the wrap. That is your P1, P2, P3, so forth. CAA is 70 and 100 and 100 on the 3 products of this blend, and the percent retained. So with all that information provided in the tables above, you simply plug in those values into the equation. To your multiplication, then you divide those values for the 3 aggregates used. Just follow the sequence of the equation, and our blended CAA will be a 95.2 rounded to the nearest whole number, which yields us a 95. So let's move on to our sand equivalent values that we achieved in our individual testing of our natural sand and our B sand. Let's look at the equation there underneath the table to get familiar with the equation, which is similar to the coarse aggregate angularity. SE1 represents the measured sand equivalency value that we performed on each product. We're going to multiply that by the percent passing the number 4, which you see in the table above that will be provided, which is 22% on natural sand. And P1 represents the percent of that material in this blend. So in this case, we will be looking at natural sand and B sand. The second set of parentheses underneath is the percent passing the number 4 times the percent material used in that blend. Divide those two, follow the equation step by step, and we will eventually arrive to an 88.6 blended sand equivalency for this particular blend, and always remember to round up to the next highest whole number, which would be 89. So now we will turn our attention to blending the FAA values. Let's look at the formula in the middle of the page underneath the table. FAA representing the fine aggregate angularity value that we gained running each test on both products. Something different in this one is the percent passing the number 8 sieve. our prior blending was concentrated on the force of. Just wanted to point that out, that we're going to be multiplying our FAA value by the percent passing the number 8. Then we're going to multiply that by the percent of material used in this particular blend. Underneath, we're going to divide that by the percent passing the number 8 times the percent material used in this blend. Using the table above, plug those numbers into the step-down formula below, and we will arrive at a blended FA value of 47.0. Now we will be looking at our F&E blending the two aggregates on blend number 1. The table in the middle of the page is our F&E values that we obtained on the number 8s and on the number 78s. The percent retained on the number 4 at the bottom of the table for our 8s and our 78s, and the percent used, 8% and 28% respectively. So let's look at the equation at the top of the page. F&E, of course, is the value on each product. The percent retained on the number 4, and we're going to multiply that by the percent of the material used in this blend. Then we're going to divide that by the percent retained on the number 4, multiplied by the percent of that material used. So use those values, plug in the values on the step-down example below the table, and we will arrive at a blended F&E on blend 1 at a 6.5. So now the last part of the blending of the aggregate properties, we're going to focus on blending our gravities and absorptions. So we're dealing with 3 different blends. Our first blend, the material used in blend number 1 is, we're using 8s, 78s, natural sand, and B sand, and baghouse fines. This blend here doesn't have any wrap in it. So let's look at the equation at the top of the page. P1, P2 simply means that is the percent material used in that blend. The bottom part of the add equation, where you have your percent of the aggregate used in that blend, we're going to divide that by each individual gravity. So it would be 8% of the number 8 divided by that gravity. The number 78, 28% divided by that gravity. So if you look at the equation underneath the table, that kind of spells that out, where the 8 and the 28 and the 22 and the 41 and the 1 represent the percent used of each aggregate by its gravity. Follow the step down of this equation, and you will arrive at a 2.722 blended GSB of that blend.